Hello and welcome back. We have another exciting presentation by Lojas Renner, designing and simulating a multi-depot omni-channel. So the presenter today will be Guilherme Colo, and I apologize, Guilherme. Thank you again.
Thank you. I'm gonna put my presentation now on presentation mode. Can you guys see it? Okay.
Yep, looks good. Thanks.
So thank you, Max. Hello, everyone. My name is Guilherme Coelho. I'm a project specialist and leader of the optimization and simulation team of the logistics department at Lojas Renner, based in Brazil. Today, I'll share with you some thoughts on how to design a multi-depot omni-channel last mile operation using AnyLogic and a VRP solver. All right, first, on this slide, I give a quick overview of our company. Lojas Renner is the largest fashion retail company in Brazil, with 5 businesses, more than 600 stores, and 4 distribution centers. We have more than 24,000 employees based in Brazil, Argentina, and Uruguay, a growing e-commerce operation, and a rich online marketplace. Our motto is to give an enchanting experience throughout all our businesses. Here at the company, we are building a fashion lifestyle ecosystem, which is represented by this mandala. As you can see, this ecosystem accounts for all our businesses and services, but today I'll focus on our omni-channel operations. Our omni-channel has a couple of objectives, such as positioning our inventory on the right location, delivering faster and cheaper, improving assortment availability on our website, and most of all, to use and exploit our store capillarity. Remember, as I said before, we have around 600 stores in Brazil and at least 1 store on every state capital. It's very important so you can understand the goals of the case study I'll show next. So our current logistics operation consists on managing few large distribution centers and many retail stores. For the e-commerce operation, we can dispatch packages from our distribution centers, but also from our stores. All packages are shipped with third-party carriers, and because of that, we may have high delivery costs and long lead times. So we actually studying to shift from this framework and to start to manage our own dedicated last mile couriers, using our retail stores as transit points to deliver to customers. Only on São Paulo metro area, we have more than 50 stores. So our first question is, how can we exploit this? How can we use this capillarity for our benefit? After we answer this, we can start to think about how many couriers would be necessary to deliver our packages. How much would it cost? How long would they work per day? But also, how can we account for failed deliveries or delivering to risky areas, or even how to handle special sized packages? We came up with these questions because we are not really a logistics company. We are a retail company. So to get a new advantage on the market, we actually have to think outside the box a little bit and try to understand how can we improve logistics, how can we enter this logistics world and trying to improve, reduce costs, improve lead times. So for this case study, assume a fixed set of stores as transit points and coverage area. The determination of the transit point locations and their coverage is beyond this presentation. However, it can be achieved, for instance, by solving a facility location problem, k-means, and any kind of any kind of solving algorithm like this. Then we need to simulate the actual delivery operation. We have to account for random delivery locations, random delivery times, random delivery failures. And each transit point has its own couriers of different types. Finally, the challenge here is to simulate the actual delivery routes. For that, we have to solve a vehicle routing problem for each transit point. So on this slide, I show the general courier workflow of our simulation model. The couriers are created at the start of the day at their specific store to load packages. At this point, a new route is assigned to the courier. The courier then starts the route by moving to a customer location and attempting to deliver a package. When the courier is done delivering, if there was any failed delivery, or if there is still remaining package at the depot and he has still available time to work, the courier will return to the depot, in that case the store, to load a new set of packages, and the cycle starts over again. And then this is a screenshot of our simulation model. As you can see, we have modeled this operation use the process library. We have some agent modeling features as well. And the GIS, and we use the GIS features with some histograms for visualizing some statistics. AnyLogic has very intuitive GIS features, and they are relatively easy to set up. It's also easy to expand it with Java-based libraries. But as you already know, it does not come with any VRP solver. So just for a quick review, in a vehicle routing problem, there is a starting point for all routes called the depot. In our case, that's the store as transit points. The routes may be assigned to different vehicles with specific capacities, queues, speeds, and maximum work times. There are many VRP solvers on the market. I'm showing here 3 open source projects that you can check out later, and 3 general purpose solvers, Groby, Cplex, and Express, which can be used to implement this kind of problem. As for this case study, I will show how to expand AnyLogic with the JSprit VRP solver, the one with the green square. So according to the developers, JSprit is a Java-based open source VRP and TSP solver. It's very flexible and easy to use. You can solve multiple types of VRPs with pickup and deliveries, timing windows, multiple depots, SKUs, multiple capacity dimensions, and other parameters. It's also possible to add custom constraints to enrich the solution algorithm. On the following slides, I'll go through an overview on how to model a VRP with JSprit. And just a disclaimer, I do not represent them. I just found that this open source project was very useful for this simulation model. So let's go on. First, we have to register our vehicle types. The vehicle type must have a name and other optional parameters. You can define any number of capacity dimensions. Here, I have included just one dimension, the limit on the number of packages loaded at the depot that a vehicle can carry. You should define a variable cost per distance and a fixed cost for each vehicle type. This will make the solver evaluate the trade-off between adding a new vehicle or using one already in the solution. Also, you can add any data that might be useful for custom constraints, cost, or time functions. Then register the available couriers and assign them a vehicle type. In this case, I have defined a specific number of couriers for each type, for each vehicle type, but you can let the solver choose by itself if you want. Also, you must define the starting point of the courier, which here is the store they are allocated at. Then you can register our courier-specific skills, such as it can transport large packages, or it cannot deliver to risky areas, for example. Finally, you might want to set the courier total time worked as the earliest start and a total work time constraint as the latest arrival. Next, you have to register all delivery points and the time necessary to deliver them. In the simulation model, you might be using a random distribution for the delivery time, but here just go with the average. For each delivery, there might be a set of required skills the delivery one will only be assigned to a courier with matching skills. For instance, we have some high-risk locations that can only be served by motorcycles or cars, but never with vans. Also, if you have large packages to deliver, you might determine that motorcycles cannot be assigned to them. Then, register the distance matrix and cost function. For the distance matrix, you can use the straight line distance or the distance by route. Depending on the size of the problem, you can call external web APIs from Google Maps or OpenStreetMap for free. And next, you have to define the cost function. Here you can use the variable and fixed costs registered for each vehicle, and also any other custom parameter. Then register the transport time function. Here you can call the distance matrix and vehicle speed to determine the time necessary to cover the distance between deliveries. On our simulation model, we assign a new route for the courier each time he visits the depot. Because of that, we have included a custom parameter to account for the pickup time. We have included the pickup time in the transport time function, but is added, as you can see here, to the transport time only if the starting node is the depot. So it's right here. I add the pickup time, and I calculate the pickup time. I define the pickup time here, and if the depot is the starting node, if that's the starting node, I consider the pickup time. If not, it's 0. Finally, you can beat the VRP problem by adding the distance matrix, vehicles, and deliveries. Make sure to define here if the fleet is finite or infinite. And the last step is to set the solving algorithm by adding the VRP problem built before and the cost function. If you want, you may set the number of CPU threads to be used and timeout in milliseconds if you think that's necessary. For this model that I'm going to show you next, I have used 30 seconds to run the VRPs. Each time a vehicle enters the depot, I rerun this, but you can change this parameter if you want better solutions. Actually, you can play with that and see if that improves anything. So here I'm going to show you how our model runs. At the beginning of the day, all deliveries are randomly created. All couriers are created at the start time defined in our input file. Here, they all start at the day at 8 o'clock. For the sake of this example, I have considered the distance between points as straight lines. As the simulation runs, red points start to appear. These points represent failed deliveries with 5% probability. When the couriers cannot continue working, they are destroyed in the model to be created again on the next day. On the second simulation day, another set of deliveries is generated and added to the ones that were not delivered on the previous day. I am collecting some statistics on these two histograms. They show the variability on the total time and distance worked per day per courier. And finally, I zoom in so you can see with more detail the routes. As I said before, you can play with some of the parameters on JSprit to try to improve these routes and see if you can add some computer time to the solution and see if you can improve it. And as you can see here, at the end of the simulation, there was many deliveries that were not completed. So that means that at some point, this depot here that's up here that I cannot show you, but it's up here, does not have enough coherence for the demand on its coverage area. So that's one of the outputs of the model. You have to increase the number of coherence here. All right, and some final thoughts. Designing any logistics operation is a challenging endeavor, as you may already have seen on previous presentations, right? Many decision variables, many good different strategies, and many specifics for each locality. Here in Brazil, we have to do a lot with risky areas when we're playing our last mile operation. That's not really easy. Choosing the right tool is essential, especially considering time and budget constraints to deliver a project. AnyLogic is a great tool for that because it's very broad and we can model pretty much anything we want. But there are some specifics that we have to handle, like this VRP solving issues. But again, we can use Java to expand it with not much an effort. AnyLogic provides various modeling alternatives for the same problem. And as I said, there is no real right answer here. You might model something this way or the other. You have to just focus on the final objective and the final goals. And then complex problems might require complex solution processes, but there is no need to reinvent the wheel every time. As I showed you, there might be an open source project related to your problem. This is just one example on how to do this. I bet you can use some APIs from Google Maps or other companies to do the same thing. But I wanted to show you how to do it locally. But again, you have to check if that's applied to your project and your problem. Thank you very much. And let's see if we have some questions. No questions yet. Got one question here. Are you going to upgrade it to RL? Well, I saw the last presentation, one of the last presentations on RL. I don't really think that it is applied to this kind of problem because I don't really need my agents to learn or to define an algorithm on how to think and how to handle situations. I just need the routes. So there are classic and well-known algorithms for that. And sometimes you just have to go with that. How long does it take to run the simulation? Well, that depends on the timeout parameter you use on the VRP solver, and the size of the problem and the number of depots, right? Here in the company, we are running a small problem still. We have one depot and we are trying to estimate the routes. It can take 5 minutes, 10 minutes. That depends on the demand that you're simulating. How can you extend your model to a more complex situation, more elements on the network, or can easily be done? Well, I mean, easy is relative, right? You might need to reveal the VRP solving, right? I know that JSprit has many alternatives that you can, as I showed you here, you can model delivery operation with many different ways, and you can use constraints, and you can use custom parameters, and you can use custom functions, and then you just have to merge it with your simulation model. So I think that depends really on the situation. Depending on the situation, you just have to change your flowchart, your simulation model. But depending on the situation, you have to change your VRP algorithm. Okay, no more questions. Just a second. Okay. Do you update the routes every day based on the current client orders, or you build fixed routes with some demand forecast? So here, to build this simulation model, I have some historical data, and I generate random delivery points based on this historical data, right? So I have the latitude and longitude for each client. Actually, here I have the latitude and longitude for each zip code of the clients, and I raffle this demand points each day of the simulation day, and for each day I generate the routes to attend them. So it's not really actual delivery from our customers, but that's historical data. And you can also use a demand forecast. I mean, that's just the input. Did you try using the GIS feature with live traffic using external traffic APIs? No. I have some parameters that define the speed of the vehicles during the day and during the afternoon. Here in the model, I consider that the deliveries do not occur at night. So I have to do some research on the average speed on São Paulo during the morning, during the afternoon. I tried to look for external traffic APIs, but I couldn't find any easy to use here. If the one that put this question could reference somewhere that I can take a look, I would be really grateful. I think that's the last one. I would like to ask you to expand on actual business use for this model right now, other than determine if there are enough couriers at each location. Also, any plans to extend the model into online digital twin. So this model is used solely right now to determine to estimate the cost from this operation and to determine how many couriers we will need. And because of this, the journey that the couriers do during the day, we have to check if the total time worked is greater than the one that we have in contract. So that determines how much will it cost, and we have to change to to increase the number or decrease the number of the couriers depending on that. So that's the main objective of this simulation function, this simulation model. And then any plans on extending into online digital twin? Not for now. Not for now. I think that as the last presentation guys said, that is very it's not really easy to do, to build a digital twin. We have to start it now to collect the benefits in the future, but I think that's something that we have to think about. Could you share your slides so we can learn, make sure that's working? Okay, I think the slides are going to be shared with everyone in the website, right? Not sure how you'd like to address this Google API distance matrix. Well, you can call the Google API. There's actually a distance API there, a distance matrix API with some limitations that you can call for free, if I'm not wrong. But you can also use AnyLogic on GIS features to calculate these distances, right? So if you guys want, you can send me an email. I can show you later. But you can use AnyLogic map features to actually calculate these distances by road, right? How was the model able to handle car-bike routes, or did you use arc length between two coordinates? So in this model, I can use distance by route, and I can add a number of different vehicles, and each vehicle has specific parameters. So that's just it. I can change the speed for each vehicle. Very flexible. Okay, what else? AnyLogic include car routes. Yes, you can call, as I said before, you can call the map functions and get this distance by route. The last question, just to wrap up, do you consider totally successful project? I mean, if you get all you wanted to reach? Not yet. We are here. We are aiming to expand this simulation model in something more. As you saw in the presentation, I start by assuming that I have already defined the location for the depots and the coverage for each one. So at some point this year yet, we are going to expand this so we can do everything at once. So we want to do the facility location, define the location for the depots, the coverage, and the number of couriers necessary to attend the city, and the cost for this operation. And we are going to use this simulation model as a validation model, or just to expand it and do the optimization with it. Okay, I think that's it. Thank you, everyone.
Thank you so much for your time, Guilherme. And please, if anybody else has questions, you can message the presenter directly in their bio.